Hello everybody, this video is going to be about triangle congruence theorems, three in particular. The first one that we're going to start with is ASA, which stands for angle side angle congruence. As you can see in the picture, there are two corresponding angles that are congruent. A is congruent to D, C is congruent to F. And the side that joins the two angles is also congruent to each other. So that's why it's angle side angle. Okay, so you do pay attention to the order. Since these angles are corresponding, that's how we get our order. You want to go in order based on which angles are across from each other. So you go from A to B to C, or you could have said C to A to B. It doesn't really matter as long as you're going in order. But as whatever order you choose for the first one, you have to do the same order using corresponding angles. So since D is corresponding to A, D is going to be first, and so on and so forth. So now that we know what that is, let's apply it. So for this next one, we have two triangles, ABC and PRQ. So we know, and I'm sorry, that shouldn't say SAS, that should say ASA, sorry. Okay, so we know that angle A is congruent to angle P. So we got the first angle. Now we need to go to the side. The side that joins the next one, we're going to call that line AC. We know that that is congruent to line PQ. Notice that I'm going in the correct order. Since A is congruent to P, and I put A first and I'll put P first, so PQ. We know that those are congruent because of this tick mark here. It's the same amount of ticks. And the last thing that we know, so we got the angle in the side, and the last angle, the one that joins the two, is angle Q is congruent to angle C. So since we have these three pieces of information, we know that by the angle side angle theorem, a triangle ABCD, or ABC, excuse me, is congruent to triangle PRQ. And it's very important that you put your letters in order. So this one is SAS for real this time. And it stands for side angle side. So as long as you have a side, the next angle, and then the next side that are congruent, then you know that your triangle is, both your triangles are congruent. And it has to go in that order, just like with the last one. So let's use SAS to prove this one. So here we have what we call a vertical angle happening right here. And what vertical angles are is they're formed by intersecting lines, and they are non-adjacent angles. So this angle is congruent to this angle right here because they're formed by the intersecting lines like that. All right. So we know that the angle X, Z, Y is congruent to the angle V, Z, W. So angle X, Z, W is congruent to the angle V, Z, W. Now the reason why I put the second one in that order is because V is corresponding to the X. Why? Because they have the same amount of tick marks. They have the same line length. So that's why I put it in that particular order. Alright, so now that we have identified the angle that's congruent, it's in the middle in between these two lines that we know are congruent. So WZ, here to here, we know that is congruent to YZ. And I'm putting in that order because of the way that our triangle is listed. Okay? So that's how I got this second statement here. And then we also know that VZ is congruent to XZ. So I've got my side, my angle, and my side that are congruent to another in that order. So by SAS, the triangle XYZ is congruent to triangle VWZ. The last one is side, 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 which is pretty easy. As you can see in the picture here, each corresponding side has the same length. So if all the corresponding sides have the same lengths, then that means you can conclude that they are congruent. So let's try one example. Here we have kind of a weird one. We have two triangles here. The first one is ABCD right here. And the second one has an adjacent line with it. The second one is the first one I just did was actually CDA. Sorry about that, CDA. And this one is ABC right here. So they're sharing the same line. Okay? We can see that the first line is congruent. Well, AD is congruent to CB. We can also see that AB is congruent to CD. The last line is right here. We can see that AC is congruent to CA because they're the same line. Now the reason why I changed the order is because look at the order in the second triangle. For the first triangle, they listed as AC. For the second triangle, it will be listed as CA, but they're the same. So since all three lines are the same, we can prove by SSS. So we know that. So since we have the following information that all three of the sides are congruent and in the corresponding order, we can conclude by SSS that the triangle ABC is congruent to the triangle CDA. Thanks for watching.